All right, welcome, and we're going to be talking about the AP Review number 3 that's on derivatives to give you some reminders of some derivative rules that are important, and in particular, looking at some slightly more complex derivative situations, definitely to be ready for being flexible with applying, especially things like the chain rule or the product rule or the quotient rule or those things together, okay? So I'm just going to walk through a few examples and talk through some things just to be aware of. Here we go. Let's say we have this function f of x, which is the quantity x minus 1 times the quantity x squared plus 2 cubed. Then let's find the first derivative. All right, so I'm looking at this. I see we have something times something else. We have, if you want to use my Dorito math language, we have like Dorito times box, right? But what's difficult here is that this box is really something cubed. But our biggest structure here is we have a product of two things. So I want to start off with product rule, but when I get over here, I want to recognize that this looks like a chain rule. I have an inside and an outside function. So big scale picture, we have something times something, but then that second something is itself going to be a chain rule. So let's walk through this. All right. Product rule says keep the first x minus 1. Then we need the derivative of the second, but then the derivative of x squared plus 2 cubed is going to be a chain rule. The derivative of that second thing, I'll bring down the 3, keep the inside, and then that would subtract 1 from the power. So I did the derivative of the outside. I did the derivative of the outside here, which is something cubed, the cubed part of that. Kept the inside, and then the chain rule says after I keep the inside, I multiply by the derivative of the inside, which will be 2x. All right, and then when I add on to it, what I get when I take the derivative of the first function, derivative of x minus 1 is just 1. So that's just 1 times, keep the second, which is x squared plus 2 cubed. So I kept the first. This whole thing over here is the chain rule. This whole thing here is the chain rule. That's the derivative of this second part. Plus the derivative of x minus 1 is just 1 times, then I kept the whole second part. Now here's what's kind of difficult about this question, though. I mean, this is the first derivative, but even if we kind of simplified stuff, we wouldn't quite to get anything that looks like any of these. So I have to do a little bit of work. Let me just start cleaning some things up here and see kind of what I get to. I'm going to multiply some things together that are relatively easy to multiply together, like the 3 and the 2x and things like that. I want to call this then 6x, x minus 1 times x squared plus 2 squared plus, and then I'll have this other part. It doesn't really have anything it can combine with, so I'm just going to leave that there. All right, so you might go, well, how do I go from then this expression, which is still my first derivative? How do I go from this expression then to one of these? All these over here look factored. Some of them you might go, well, that doesn't make any sense to be able to get something like a, and you're right. But we'll just walk through this kind of strategically. I want to flip back and forth between two different pins here because it actually kind of makes sense to color code things a little bit. Here's what I notice. I notice that there is an x squared plus 2 squared, x squared plus 2, I mean, in each of the terms here, right? So let me go ahead. I want to factor that out. Let me factor that out. I see that x squared plus 2 squared, x squared plus 2 cubed, so I can take out 2 of those x squared plus 2's out of each of those. I want to call this x squared plus 2 squared. And then what am I going to have left over on the inside? What am I going to have left over on the inside after I factor out x squared plus 2 squared? I'm going to have 6x, because that's not been touched, x minus 1. That's not been affected. I took out both of these x squared plus 2's. Plus, I took out 2x squared plus 2's, but I'll leave one more over there, x squared plus 2. All right, now there's nothing more I can factor out, so I just got to clean up this inside. All right, so this is going to be equal to, let me clean up this inside part first. This is going to be 6x times x, that'd be 6x squared minus, distribute 6x in there, minus 6x, plus x squared plus 2. And I will still have the quantity x squared plus 2 squared on the outside. All right. Clean up a little bit more. X squared, 6x squared plus x squared will give me 7x squared minus 6x plus 2 when I combine like terms. I want to get rid of the color coding now because I should be about done. This will be x squared plus 2 squared. All right, and look, we get d here. So we need to be flexible with a couple things. We need to be flexible not only with applying the product rule, with part of it being a chain rule. We also need to be okay with doing some cleaning up if we need to. I know in the free response questions this year on the test, you won't have to do any cleaning up. You should just stop right here. But flexibility in terms of factoring and things is a good math skill. All right. Here's one example. Big takeaway here. Be aware of your product and product plus chain rule. That's not how you spell and product plus chain rule. Okay. If you need extra work on that, just let me know. I can get it to you. Product plus chain rule. All right. Let me know if you need more of that kind of practice. Here we go. Moving on. All right. We also need to remember our limit definitions of a derivative, and that's what 5 and 6 are asking us about. Remember, there's two different limit definitions of derivative. One of them says, well, a derivative, I could call it this, the derivative of f at a is going to be equal to the limit as h approaches 0, f of a plus h minus f of a. Kind of lost my minus on there, didn't I? Minus f of a all over h, where h is the distance between the 2 points I'm taking my slope. So the distance between the 2 points I'm taking my slope gets smaller and smaller and smaller. My 2 points where I'm making my slope get closer and closer together, so I get the slope of a tangent line. Now, if I see this kind of limit form, it really means the derivative of f at a, the derivative of the function I'm seeing at the a value I'm seeing inside the parentheses near the h. So coming up here, what is this? This is really taking the derivative of the function. The function looks like sine of a plus h. I'm going to take that whole, because that's all replacing x. Sine of x, think of it that way, sine of x is my function. A plus h is replacing it. My a value, where I'm taking the derivative, is pi over 6. I know that because the sine of pi over 6, f of a, is half. So there we go. So what's the derivative of sine? The derivative of sine is cosine of x. And then I need f prime of pi over 6. So the derivative at pi over 6, the cosine of pi over 6 is square root of 3 over 2. All right. Now, number 6 over here is talking about another, like our other form of our limit definition of a derivative. It says that the derivative is going to be equal to the limit. This one's usually a little easier for people to see. As x approaches a. So as my x value approaches the place I'm trying to take the derivative of f of x minus f of a over x minus a. All right, and all this is saying is, hey, let's make our 2 points, our x values, get closer and closer together, and find the slope between the points there. And as those 2 points get closer and closer together, this is going to basically be the limit of our slope formula, our secant line. As the 2 points get closer and closer together, we'll get a tangent line. So I can apply this up here. I can see my function. I'm taking then the derivative of this function here at this value here. We can also see that a value there. Okay. So in this case, our f of x function is sine of x, and a is pi over 4. So the derivative of f at pi over 4, derivative of f at pi over 4, derivative of f is cosine of pi over 4, cosine of pi over 4, which is going to be root 2 over 2. Okay. Now, if you ever get stuck on these, you can also use L'Hopital's rule at this point. But it is better to recognize that these are really definitions of derivatives. It's asking us to take the derivative of sine at pi over 4. All right. So there's a big takeaway there, talking about limit definitions of derivatives. The limit definition of a derivative. That looks like limit definition. That's a D. Definition. Okay. Cool. Let's keep on moving. What's our next one looking at here? All right, find the derivative of the function. Okay, find the derivative of the function. We have 2 plus 3t quantity to the 6/5 power. Okay, find the derivative of the function. We need f prime, so let's take a look and analyze what we got going on here. Our function looks like we have Dorito something to the 6/5 power. All right. Okay, so if that's our function, this is going to be a chain rule. We have an inside and an outside function. Inside and outside function. So I can do that. I can take my derivative using my chain rule. The chain rule says take the derivative of the outside function first. So I'll bring down the 6/5. It's a power rule thing. Take the derivative of the outside function first. I take the derivative of the outside function first. So I bring down the 6/5 power. I'll subtract 1 from that, which is 5/5. So it'll give me 1/5. 1/5 left over, multiplied by the derivative of the inside, which is 3. And then I can do any cleaning up that I might need to be able to do. 6/5 times 3 is going to give me 18/5 times 2 plus 3t to the 1/5 power. Let's see if we see that anywhere. Oh, look, there it is right there. So that's going to be my answer. So the big takeaway here is the chain rule. And the comment I want to make here, yes, you do need to know your chain rule, but you need to be really flexible with it. Be okay with the fractional powers, dealing with square roots, dealing with all your different derivative rules. For example, I'd push you. Have you gone back and re-looked at what is the derivative, for example, of the tangent inverse of x? If you've not, go back and relook at it, and those other ones that you maybe have not spent some time with in a while, make sure you know all of those and how to apply the chain rule to them. I would also point out that it is worth remembering the function notation of how to do the chain rule and your derivative rules as well. For example, the derivative with respect to x of f of g of x would be take the derivative of the outside, keep the inside function, times the derivative of the inside function. We need to be comfortable with it in function notation too, because sometimes that is how things are worded on the free response questions. You need to be ready to recognize those things as well, not only apply them to actual functions. Right, let's keep on moving. All right, find the derivative of the function. What do we got here? We have cosine of 6x to the 4th minus 4. That looks like another Dorito math thing, another chain rule thing. We have cosine of Dorito, cosine of something, right? We have an outside, we have an inside, so let's go ahead and find our derivative here then. So y prime is going to be, remember, chain rule, I'll start with the derivative of the outside, just like I wrote up there a minute ago. F prime of g of x times g prime of x. So what is the derivative of cosine? Derivative of cosine is negative sine. I'm going to keep that inside function where it is. Keep that inside function where it is. Then multiply by the derivative of that inside function. Derivative of 6x to the 4th minus 4 is going to give us 24x cubed. And we can clean that up. That'll give me negative 24x cubed. Negative 24x cubed. Sine of 6x to the 4th minus 4. Let's see. Just make sure to make a mistake in there. Always worth double checking before making a conclusion. Great. Negative 24x cubed times the sine of 6x to the 4th minus 4. So we're looking at B here. Here, if you got A, it looked like you lost your x cubed. Here, you forgot the derivative of cosine is negative sine. Here you didn't take the derivative of cosine. Here took the derivative of cosine correctly, but then said the derivative of the inside was just 6. So looking at B there. Okay, and our very last one as an example. Sorry, this one is another reminder of chain rule. Be ready for chain rule. All right. And 14, what do we got over here? X squared sine of 2x. Now this one looks a little tricky. Remember, this really is a product there. So we do have a product rule, and this is really sine of 2x in there. So we have a product and a chain again. We have x squared times something, and that something is a chain rule. We have sine of, what's on the inside of that? 2x. So we have another product. I'll call it P plus C rule kind of problem. Okay? So we can go ahead and start that. dy dx is going to be equal to, keep the first, times the derivative of sine of 2x. Well, the derivative of sine is cosine, and I'll keep the inside, times the derivative of the inside, which is 2. Okay, there we go. First part of the product rule, keep the first derivative of the second, but the second was a chain rule, plus, then we will take the derivative of the first, which is 2x, and we'll keep the whole second function, which is the sine of 2x. All right, we can do a little bit of cleaning up. This will give me something like 2x squared cosine of 2x plus 2x sine of 2x. And hopefully that matches up. It doesn't, so we have a little more work to do. But I noticed it looks like some things were factored in parts in answer choices C through E. So is there anything I can factor? Yes, it looks like there is something I can factor. There's a 2x here and a 2x there. So if I factor that, I'd end up with 2x times the quantity. 2x out of 2x squared will give me just an x and a cosine. 2x there left over. Plus the 2x came out of that, so I have sine of 2x left there as well. Let's see if that matches up anywhere. 2x times sine of 2x, and I need a plus x cosine of 2x. That's missing the x. That's a minus. I need a positive x cosine of 2x. There it is right there. Okay. Another product and chain rule mixed together. So hopefully this gave you a quick sort of warm-up and review of certain things to be on the lookout for when it comes to derivatives and derivative rules. I would emphasize to make sure you are comfortable with all of your derivative rules, as well as the function notation form of your product, chain, and quotient rule. I know I showed the chain rule one earlier, but also be comfortable with the product rule and quotient rule function notation forms, which are as follows. If I'm trying to take the derivative of f of x times g of x, this is f of x g prime of x plus f prime of x g of x, or the commutation of those. You can switch the order there. And then our derivative of f of x over g of x, so the derivative of a function that is a quotient, is our classic low d high minus high d low. There the order does matter, all over the low function squared. All right, be on the lookout for those. Please now go ahead and try the practice problems below. I'll put that back in case you want it. Try the practice problems below. They are designed to help practice a variety of derivative skills that you will need. Some multiple choice ones, practicing different things, be on the lookout. Some of them are meant to be tricky. Some open-ended differentiate, and you have to figure out all the rules that you need. And then some free response questions I want you to try, okay, around differentiation and finding derivatives and continuity-related derivative things, okay? Please make sure you do that. Come back and check your answers against my answers and the videos I will post and fill out the score report. Talk to you later. Bye.